And thanks everyone for joining this late afternoon session, and welcome again to reInvent. My name is Stefano Sandrini. I currently lead a team of solutions architect covering small and medium business in Europe, South, and France, so covering Italy, France, Spain, and Portugal. Today with me, we will have David Gonzalez, CTO of Cires21. Together, we will show you how Cires21 is revolutionizing advanced video workflows using AI on AWS. In the last 7-8 years, I've been lucky enough working for AWS to work with many media and entertainment customers. In general, at AWS, what we see based on our conversations globally with these customers is that industry leaders and decision makers decide to use AWS to run their media and entertainment workflows, mainly because of three main key reasons. The first one is the deep expertise and knowledge of AWS in this specific industry. So decision makers, basically, they want to leverage these expertise to drive and accelerate the digital transformation of their company. The second reason is about technology. So as AWS, we provide purpose-built services as well as pre-built solutions that our customer can use to leverage cloud data and AI technology, again, to accelerate the innovation of their product, innovation of their services, innovation of their platform, innovation of their operations. The third reason is about partners. There's a large ecosystem of AWS partners that are heavily focused on media and entertainment use cases. So when we work together with these customers in the media and entertainment industry, these customers can find the right partner for the use case, the right partner that can fit their business needs and unique business requirements. And together with us and the partners, we can accelerate the time to value for those customers. So these are the three main reasons. And when we start working together, AWS, the customer, and the partner, we see impact in 6 main areas. So we have like 6 solutions areas for media and entertainment. Of course, there are areas related to classic media and entertainment use cases, like content production, media supply chain, archive, broadcast, live production, direct-to-consumer, and streaming. But there are 2 areas that I want to highlight because they are related to a very common and important topic nowadays in media and entertainment industry. And the topic is reinventing monetization across all channels. This is mainly due to the fact that, of course, the media and entertainment industry is going through a transformation in these years, right? And media entertainment customer, they want to actually use data and analytics to have a better understanding of their customer base, to enhance the customer experience while consuming media content, of course. But of course, also to provide a hyper-personalized set of contents for those customers, or for types of customers, cohorts of customers, right? But also the data is used to acquire new customers, for example, by doing specific advertising, specific targeted advertising based on the data that we can collect together. But it's not just about these 6 main areas. It's of course about talking on the impact of generative AI in the media and entertainment industry. You see here 5 main and common use cases of generative AI applied to media and entertainment: archive and restoration, enhanced broadcasting, localization, very important, of course, for market penetration. You create a content for a specific language and a specific geography, and then you want to penetrate other markets by doing automatic dubbing or automatic closed caption, for example. Very classic. We already talked about hyper-personalization, but there's one more thing, which is video semantic understanding, something that I really like to talk about. So understanding the semantic meaning of the video content. So then I can search using semantic search, and I can create new contents based on what I already created in the past for repurpose, for example, for social media and social channels. We will see some of these use cases together with David. So, without any further ado, I would like to ask David to join me on stage to show the MediaCopilot from Cires21.
Thank you, Stefano. Hi, everyone. Cires21 started its business almost 20 years ago. We are a company very focused on providing live streaming services in Spain. Our main clients are broadcasters. And 2 years ago, we started to develop our own AI pipelines. As we work with our customers, with our clients very close, we know very well their workflows. So we noticed that they were using different applications with a very fragmented ecosystem of applications for their regular operations. This caused low content delivery and high cost. And there was a lot of duplicated work even. So that's why we decided to develop MediaCopilot. MediaCopilot is a unified platform that integrates a lot of different capabilities of AI models. It also is orchestrated by agents. It offers faster content delivery and lower cost. So let me dive into the details of the architecture. This is a classic serverless architecture. We decided to go serverless because it's a much faster time to market, and it offers reliability and scalability. So the API uses Lambda, API gateway. We use step functions as the core of orchestrator of all the workflows of MediaCopilot. We also use SageMaker. We will talk about SageMaker later. Amazon Cognito, that offers us the capability to offer two-factor authentication, single sign-on. And also Amazon CloudFront and S3 that offers not only delivery or worldwide delivery, but also content protection. So one of the main reasons why we chose AWS was media services. Media services offer us the services that we need to transcode video. So we use MediaConvert, for instance, to transcode all the assets that have been uploaded by our clients to CMAP to send the video to the rest of the AI models. And we use MediaLive and MediaPackage to receive live feeds. And we use Harvest Jobs to do live clipping of the live feed. On top of this, we have developed a video editor that is quite useful for live clipping creation. And it's also adds the possibility to add subtitling and branding and styling capabilities. So, as I said previously, we have developed AI pipelines. So we have custom automatic speech recognition models. We have voice activity detectors, diarization, scene detection. We don't only process audio, but also video. And we use also Amazon Bedrock to create more complex metadata, like subtitles, highlights, summaries, things like that. All the capabilities of MediaCopilot are available through the API. Most of our clients use the API instead of the UI because they integrate MediaCopilot into their existing workflow, into their CMS, into their media asset management, or their live clipping service. So here, MediaCopilot acts as an AI layer for them. And 2 months ago, more or less, we started to develop agents for MediaCopilot. Fortunately, AWS released Agent Core, which is a very interesting service that offers different services like runtime, gateway, identity, observability, memory, which are quite interesting and very scalable, very secure, extensible. So it was very suitable for us. So we started by developing the MCP server. An MCP server basically is a server that has different tools. Tools are capabilities that allows to connect to different elements like databases, APIs, code. The first version of the MCP server that we developed was developed using Gateway. Gateway is a service that allows us to deploy an MCP server in minutes instead of hours, because you only need to provide the Open API specification of your API, and it automatically creates all the tools available for applications and agents. Then we started to develop the agent. We developed the agent with Agent Core Runtime. This is very interesting because Agent Core Runtime is stateless. It handles automatically the session. So for each session, Agent Core deploys specific resources for that session, encapsulating the context of the session. So this is critical for us because content protection and privacy are our main rules. So this is a very cool feature. In this specific example, the user is asking the agent to perform a complex task, like finding the best moment or the most viral moment of an interview, create a vertical clip for social media, and then burn the subtitles and export everything with the captions to external metadata automatically. So this is one simple example of what the agent can do. We also use memory. Memory is a service of Agent Core that provides short-term memory and long-term memory. Very useful to recover all the context of past sessions. And we use long-term memory to store preferences of the user. So the agent can learn from the user what are their preferences in terms of styling or in terms of text generation. Observability is also a very important service for us because it allows us to monitor everything that is happening in the sessions of the agent. So we can identify bottlenecks or we can optimize the workflow. And the lessons we have learned so far, developing MediaCopilot has been very challenging. One of the lessons that we learned is that it's quite important to select the right deployment model in SageMaker. SageMaker offers different deployment models. We are using a synchronous inference endpoint that is very good for VOD, but it's not enough for live. For live, you need to use real-time serverless or serverless service. We are starting to integrate segmented video processing because if you can segment your video and process the different segments, you can run everything in parallel and reduce the time of the inferences. And serverless was key for us, as I said previously. So next steps, real-time processing for live, so we can make decisions while the live is happening. We are starting to develop specialized AI agents. We find that as you use less tools in your agents, then you can save more tokens in the LLMs, so more agents with specialized capabilities are better. And we are also integrating new models, especially visual models, to add more context to the agent. And that's all. Thank you.